if you can tell me what the converse is to a conditional statement, Rhett.
Or you put Q or P Q.
So if Q, then P. All of the theorems we are going to work with today are the converse from what we talked about on Wednesday. We talked about how if two lines were parallel, then we knew that the corresponding angles were congruent. Well, its converse is if corresponding angles are congruent, then the lines are parallel. So if these two angles are congruent, then our two lines are parallel. Says this theorem.
Made up. Yes.
Not even a little bit.
Is this fake?
Who created that?
Riches.
Charles Darwin. Albert Einstein. I think Ronnie had.
Okay, so what if I told you that angle one is congruent to angle three?
And line A and B are parallel.
Okay.
Yeah.
If I tell you that angle one and angle three are congruent, then of these four lines, okay, these two angles are corresponding with L being the transversal. Notice how L is a part of both angles. So a line A is parallel to line B. This angle and this angle are corresponding where L is the transversal. So since they're congruent, that means these two lines that aren't the transversal are parallel. If these are congruent, then these two are parallel. What? What did you say? Okay. We have the same on the next page. If two lines are cut by a transversal and our alternate interior angles are congruent, then that means the lines are parallel. Okay, so I'm going to take this same picture. Right here. So just watch me, okay? So if I said that angle 2 was congruent to angle 5, that's this guy and this guy. Okay, which line is the transversal, Carson? A is the transversal, which means if these two alternate interior angles are congruent, with A being the transversal, then L is parallel to N. So do you see that line A is the line that those two angles share? Okay, which means the other two are the potential parallel lines. And since alternate interior angles are congruent, then that makes those two yellow lines parallel. I'm telling you, that was an if. If. I didn't put the if, that was confusing. Okay, same thing's gonna happen when we have alternate exterior angles. Okay, if we have a transversal and alternate exterior angles are congruent, then the lines are parallel. Okay, if consecutive interior angles are supplementary, then the lines are parallel. Now, one just kind of like random thing thrown in here. The transitive property does apply to parallel lines. If A is parallel to B and B is parallel to C, then A is parallel to C. Okay. Okay, so we're gonna do a little, like a few different things to practice here. I want you to be turned to this side of the sheet that I'm giving you.
Sorry, my physical therapist is texting me.
Did everybody get one now that I have this table? Okay, here we go. So on the diagram, it says that E, A, J. So, you know, I'm going to highlight that E, A, J is congruent to C, B, D. Okay, so this and this are congruent. What is that going to mean? Okay, we have alternate exterior angles.
Oh, I guess you.
Okay, so which lines are going to be parallel? So hold on. What I have here in blue is our transversal because it's attached to both angles, which means what I'm going to highlight here in green, these two are my parallel lines. Do you see that? So we can name them a lot of different things. How about JK is parallel to BL? Is that okay? Okay. Now, let's talk about ABG being congruent to D. AGB. I read that wrong. Is congruent to DBG. This right here. AGB. And then DBG. G.
I'm so confused. How'd you get that? Why couldn't you just put it out?
Oh my God.
So I spelled it. I literally went A, G, B. Okay. So first of all, what theorem are we going to use? These are alternate interior angles that are congruent. Okay. RO doesn't see the transversal. The transversal is going to be whatever shares, whatever line is shared by the angle. So do you see how this orange line is a part of both angles? Okay. So then the other two lines, so alternate interior angles kind of make a Z. You see that? This is what I was kind of talking about yesterday with Z for Zach. Okay, so our parallel lines are JK and BL again.
Do you like shorten the line? Like if I put A, G, and BD, is also right? Or do I have?
That is right. Yeah. Any 2 points on that line you can name. Okay. All right. Now let's talk about A, B, D, and G, DB being supplementary. Okay, well, my only option for supplementary are consecutive interior angles. Are those consecutive interior angles? Okay. Bryce, which one is the transversal? Which line is shared by both of those green angles? BL. So there's our transversal. So our parallel lines are these guys right here. EC is parallel to HF. Seriously, you didn't have that in front of you this whole time? Okay.
Right.
You and your elbow partner, I'm handing something out. I do not want you to cut and paste. We're gonna come back. There's a proof on the back of that half sheet I wanna come back to. So don't like hack it up.
The one on the backside, right?
But I'm gonna give you about 5 minutes to go through these 18 little figures here. Can you just be quiet for like 2 seconds? Longer than 2 seconds. Every single figure has 5 lines. You need to figure out 2 things in each of those pieces. Which 2 lines are parallel and what's the reason for it? What I want you to do, originally this is like a cut and paste. I don't want you to cut and paste. Literally just write. Wherever number 1 goes, write just like 1. Just write it in, okay? You and your partner, ready, set, go.
One. Okay, Gavin.
There you go. Thank you.
No, I'm not doubting. That's the transversal. Oh, yeah.
Those are alternate exterior. Are you?
Oh, wait, no.
What?
And then. Wait, do we just?
No, these are their.
There's a couple that don't have a home.
Oh, that's not one of them.
They're waiting on that.
It would be
Oh,
my God.
They don't share a line.
Oh, yeah. 6. That's.
I know.
Because is that the transmission? Same side. That would be.
What else would it be? See. Oh, that's what's fun. Right now. It's fun. Super dark. Yeah. Yeah, please. That's the curious.
Wait, hold on. What's correspondent? Oh, wait, yeah. Oh, no, that's not correspondent. Yeah, that's
Actually, don't.
So we did. Yeah, so then let's.
I'm gonna give you 1 more minute.
Maybe it's like that.
Check it out. So 9.
Yeah, 3 is 14.
3 goes soft.
Yeah.
We are 4.
1, 4.
So we're done.
Oh, that's a. See,
Okay, I will have your attention up here, please. Your top line should be 6, 11, 8, 3.
Let's go.
Okay, I just want to point out, like, so these are, so this number 6 right here. If we have our two angles, D is our transversal, and then the two lines that are parallel are A and B. Okay, our second line, I'm really not sure why there's talking right now. Our first line, are there any questions about those four? Second line, 17, 1, 16, 13. Are there any questions there? Okay. I really like when there's the alternate interior because I like to make that Z, boom, boom, boom. And then I know that like the top and bottom of my Z are the parallel lines. Okay. Third line, 10, 14, 4, 9. And then fourth line, 2, 18, 7, 15. What questions do you have? Do you have a question?
No.
You're in? Okay, now some of you, Stella, stop. Some of you are freaking out at first. Was that so bad? Terrible. Okay, let's go to your proof. Go back to that half sheet of paper. We're gonna go through this proof. I know.
But it was the KGB.
Okay, so it is given to us that angle 1 and angle 2 are supplementary. Cool. I have no idea what you just mumbled. Well, we're gonna get there. So we know that 1 and 2 are supplementary. Now, do 1 and 2 have a special relationship of those four? No, they aren't. Okay. Now, what does it mean to be supplementary? Okay, so the measure of angle 1 plus the measure of angle 2 equals 180. Okay. What else do you know? Raise your hand. Emily. 2 and 3, okay. So angle 2 and angle 3 are supplementary because they are a linear pair. Hey Bryce, what can we say now? No, not yet, not yet. If 2 and 3 are supplementary, what's our next step?
What is your equal?
How about that? Okay, now you all know that 1 and 3 are gonna be the same. Just hold on. Okay? 2 and 3 are supplementary because they form a linear pair, which means the measure of angle 2 plus the measure of angle 3 equals 180 because the definition of supplementary. Now, you all want to use the alternate exterior angle theorem, converse. And I think that's great, but we need to have the angle 1 and 3 are congruent. You all can see that they're going to be, but we need to get there step by step. What's our next step, Carson? Not yet. So the measure of angle 2 plus the measure, well, let's do this.
That's substitute.
Let's do 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. I am flexible. You can call this transitive. You can call it substitution. I'll be flexible there. What can we do to each side?
Subtract 2.
Subtract the measure of angle 2. It really, that was like 3 major concepts that we had to string together with babies. Kind of annoying, right? I zoomed in. How many of you could see what we needed to do before we wrote all this down? That's a good sign. We just got to get there step by step, okay? Really, the worst is when we have to do supplementary. When we have angles that are congruent, okay, like, ooh, these 2 angles are vertical, and these 2 angles are going to be corresponding. Sweet, okay? That's a lot better. When we have to do supplementary, we have to go from supplementary to the addition of 1 to equal 180, and that kind of feels like an annoying step. Okay, so your homework is going to be a worksheet. Yay, worksheet. Not to be graded. Tiffany? No, you said that from over here.
No.
Okay, so the front side is half algebra, half what we did in that activity with the green sheet. The back side are your proofs. That's not necessary. So just tell me like alternate exterior angles. Okay, so on 1 through 8, people, look at 1 through 8. It says to explain, your explanation can be alternate interior angles congruent, consecutive interior angle supplementary. Get done with the first couple before the bell rings.
We actually just saw that.
Yes.